Hello and welcome to our video on parallel dot plots. Parallel dot plots are like these two examples I've got down here, where you take two sets of data and draw them on the same scale. They're very similar to parallel box plots. Draw the two sets of data on the same scale, and then you can make comparisons between the two sets of data. You can have more than two, same as box plots. My example just happens to have two. Parallel box plots are best for comparing a numerical and a categorical variable with two or more categories. My example here has got two categories, but you could have more than two and just have them piled up on top of each other. When you are comparing two or more dot plots, you must ensure they have the same scale. This one has the scale repeated, or you could just draw the scale along the bottom here. It's easier to have it drawn twice, but could be just drawn once. Once you've got your two dot plots, you need to compare the distributions. If they look similar, then there's no association between the two variables. If there is a significantly different median, is the main one we're looking for. Range and shape you can also look at. Then there will be an association between the two variables. When you write your report, you need to mention any significant differences, mainly in the center and the medians, but you can also talk about shape, outliers, and spread. That is following our SOCs. Shape, outliers, center, and spread. So center is the most important one here with the median, but you can mention the other ones as well. Here's an example. The following dot plots, they're over here, show the results of an experiment to see if there is an association between teaching style and test scores. The two classes were taught with different teaching styles. Class 1 had one teaching style, Class 2 had another teaching style. Your job is, first of all, to decide which is the explanatory variable and which is the response variable, and see if you can write a report describing if you think the variables are associated or not. I'm going to give you a minute to pause the video and have a go at answering this yourself, and then I'll show you my solutions. Pause the video now. Okay, hopefully you've had a minute to have a go at these questions. For the first one, we need to decide which is the explanatory variable and which is the response variable. So I've written down the two variables here. We could use class 1, class 2, could be our first variable, or you could have also used teaching style as a variable. Doesn't matter, either one's fine. And the second variable is the test scores. So we're going to try with our arrow going this way. Can we say that the teaching style explains the test scores? Seems to make sense to me. Let's just check back the other way. Can we say the test scores seem to explain the teaching style? Or sorry, test scores cause the teaching style. Doesn't really make a lot of sense. So we're going to go with this way. The class causes the test scores. So this one is the explanatory variable and this one is your response variable. Having a look at the report I've put together, yours might be slightly different, which is perfectly okay, but I'm going to highlight the main parts that you really need to make sure are in that report. So remember, when we are doing our report, we need to include two areas. The first thing you need to talk about is the data, including, in this case, the medians. And then you need to explain what this means. Are they associated or not? The parallel dot plots, so you need to say which display you're talking about. The parallel dot plots of teaching style versus test scores You could have used class versus test scores, that would be fine as well. Show the median score for class 1 is 87, and you should have been able to calculate that by finding the middle number from all the dots. And for class 2 it is 90. The score range for class 2, so now we're talking about the range, is 19, and it's wider than class 1 at 16. The shape of the class 1 plot is positively skewed because most of the data is bunched up to the left and the tail is out to the positive side, with no outliers, whereas the class 2 results are more symmetric with one possible outlier here. We can only say it's possible because we haven't actually calculated the upper and lower fence to see if it is an outlier or not. Overall, this shows that so this is part 2. Overall, this shows that the variables of class and test scores, again mentioning the variables, although I would definitely be using the same variables, so I might just change that. Teaching style. And test scores are associated for this group of students because the median test scores have increased significantly from class 1 to class 2. You need to make sure you have all of those highlighted points in there somewhere, but the words in between, you can have any words that make sense. And the order doesn't really matter too much as long as you are talking about the data first and what it means second. Thanks for watching the video.